To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Right, my dear children, in the previous chapters we discussed several properties of reflection. And my dear children, we discussed about diffuse reflection and the regular reflection. Okay, even we discuss about the uses of those things as well. So within this lesson part, my dear children, we'll be focusing about a fresh new topic. This is also regarding reflection as well. But however, my dear children, here mainly we are discussing about images formed by the plane mirror reflections. So you know that plane mirrors are showing regular reflections. So within a plane mirror, after the process of reflection of a certain object, an image is getting created within the mirror. Okay, an image is getting created within the mirror. Within this chapter, my dear children, we'll be focusing about the plane mirror reflections. We'll be mainly focusing about the plane mirror reflections. And the other thing is that we are going to identify the properties of plane mirror reflections. Okay, properties of the images which is caused by the plane mirror reflections. Okay, right then. So now let's head on to see what are the things given under the plane mirror reflections. So images formed by plane mirrors, that is the main topic we are going to discuss within this chapter. Okay, and the properties of these images formed by the plane mirrors. Let's see. Images are formed because of the reflection of light. So it is emitted by objects or from a plane mirror. So images are formed because of the reflection of light. So we know that images are going to create because of the reflection of light. So it is emitted by objects within the plane towards the plane mirror. Okay, that's obvious. So for an instance, the image of an electrical torch placed before a plane mirror can be seen through it. So when you keep a torch in front of a plane mirror, you can clearly observe the image of the torch within the plane mirror. So that image is getting created within the plane mirror because of the reflection of light. Let us do an activity to study how an image is formed by the reflection of light. Now it's time to do an activity, my dear children. Okay, so within this activity, we'll be investigating how or like what kind of a way does the images are going to create within a plane mirror. Okay, we'll be get to knowing some features related to the images created by plane mirrors in here. Now let's head on to see the activity then. So to do this activity, you'll be needing these materials, my dear children. You'll be needing a box, cardboard box, then a torch, then my dear children, a mirror, a plane mirror, then a stand, then scissors, then A4 sheet. Right? So these are the materials you need to get. Right? Here we are going to study how an image is formed by the reflection of light from a plane mirror. Okay? Right. So you'll be needing a box, a torch, a plane mirror, a stand, scissor, and an A4 sheet or else a white color sheet, my dear children. Right. The method. Place the white paper on the table. Fix the plane mirror perpendicular to the white paper. So I think you have got the experience now how to use the mirror and how to place the white color surface with the plane mirror, right? You know that even in the previous activities We followed these processes, right? Next one. Place the lighted torch inside the box with a long silt. Then focus beam of light to the slanted mirror plane emitted by the torch. So now according to the figure, my dear children, what you have to do? You have to place the lighted torch inside the box, then with a long slit, you have to focus the beam of the light to the slanted mirror plane which is getting emitted by the torch. As you can see here, so this is the object which is the box. So you have to place the torch over there. Then this is the silt. Then through the silt, light should be directed towards the plane mirror at a certain angle. Okay, at a certain angle you have to direct it. Now look at the reflected beam of light. What can you observe through the plane mirror? Right, now what you have to do? Like this, you have to observe the mirror. You have to observe the mirror surface. Then when observing the mirror surface, it's very simple to us that we can observe the object, right? We can observe this particular object within the mirror. So that is the one which is referred as the image, right? So image of the object can be clearly observed within the mirror, my dear children. Okay, so here get the help of your teacher to explain your observations. So now I'm here to explain the observations. Okay, but however, before we are going to take the observations, we have to do the activity. Let's see like what kind of a way we can observe the object over there. When we are placing this thing and when we are doing this experiment, let's see like what kind of a way we can observe the object. Okay, so first of all, let's carry out the experiment and let's see how we can observe the object. So my dear children, let's head on to the laboratory and we'll do the experiment and let's see what's going to happen. So my dear children, within this activity, we'll be observing how does the images are getting created by a plane mirror. So to do this activity, I have a cardboard box and a flashlight. So within this cardboard box, there is a small bit of a opening, and this small bit of an opening is right here over there. You can observe it. Here I have inserted a longitudinal area, some kind of a longitudinal part have been removed. So we'll be inserting the torch within the cardboard box. Then we'll be directing a small bit of a light beam towards the mirror by using this longitudinal section. Okay, right. So let's insert the flashlight to the cardboard box. Right, so we have inserted the torch or the flashlight into it now. So I'm going to direct it now towards the mirror. So as you can see here, it's very clear to you. Actually, I won't be able to observe this thing, my dear children. You are the ones who are observing this thing very clearly. Now this is the box, right? The real box. But however, when you are observing the image, actually the image is being observed like as the object. You can observe the image which is over here from the mirror. See? So this is the object. Actually now this object is pointing a flashlight towards you guys. But however, it is not the object, my dear children. That's the image of it. See? Now this is the real object. This is the image. Right? But however, you can observe that the object is like that, which is the one which is pointing out a light beam for you guys when you zoom it in like this. See? However, that's not the object. It's the mirror and it's the reflection of the real object, my dear children. Right then. So this is our activity then. So we'll head on to the classroom and we'll identify the other contents in the lesson. So my dear children, we conducted the activity. Okay. And now it's time to check our observations and the conclusions. So the observations and conclusions are now given in the board. Let's see. The image of lighted silt. The light reached to the eye from the object, which is the silt, which is reflected from the mirror. Now what is that? Now when you observe the mirror, right, you can clearly observe there is an object over there. And my dear children, it seems that the light is coming from that silt towards to you. Right, from that silt towards to you. Okay, that means, my dear children, actually you didn't identify the object. You identified the object from the mirror, from the image created within the mirror. You identified that one as the object. However, when I'm doing the activity, I showed you the object is in a different place. Okay, so that is our observation. That's the observation, my dear children. It's very much clear to us, right? It's very much clear to us that the object was on a different place, but however, you could observe the object as like it is in the mirror. Okay, that is our observation. So, conclusion. We see as the light reaches to eye from a point behind the mirror, it is known as the image. So, the one which we observed, the light which reached to us from the mirror, that particular thing is the one is called as the image. Okay, so object was in a different place. However, we observed the image of the object using the plane mirror over there. Okay, using the plane mirror over there. So within the plane mirror, same image has got created which is identical to the object. Okay, that's why, my dear children, you can observe that the light is coming towards your eyes from that thing, or from the image which is created within the mirror. Okay, so this is our conclusion and the observation from the activity. Okay, right then, now let's head on to see the next content. So here also we are going to further investigate about the images formed by plane mirrors. Okay, so here also we are going to carry out a certain experiment. So here we are going to draw the ray diagram of an image of pointy object. Okay, here we are using a pointy object, that means a point. So kept in front of a plane mirror. So we are going to place a point object in front of a plane mirror. Then we are going to observe the image. Okay, so when doing this activity, we'll be needing these materials. The first and foremost material, the pointy object. So as the pointy object, we are going to use a laser torch, a laser beam. Okay, so laser torch. Then, my dear children, A4 sheet. Of course, we'll be needing a plane mirror. Then a stand to fix it. Then, my dear children, a scissor. You know, if we want to cut the A4 sheet, right, then we have to use the scissor. Okay, right. So you'll be needing a laser torch. This is the one which we are using as the pointy object. Then A4 sheet, a plane mirror, a stand, then a pair of scissors. Okay, right then. So here, now let's see what is the method. Make a slit in the piece of cardboard place the white paper on the table and fix the mirror to the stand perpendicularly. So you have to take a cardboard sheet and make a silt. Then what do you have to do? You have to place the white paper on the table and you have to fix the mirror perpendicular to the surface or the A4 sheet. Okay, like in the previous activity, very simple. So here we are using a cardboard piece and we are making a silt on it. Okay, then direct two laser beams through the silt slantly to the mirror. Observe the reflected beams of light. What can you observe now? Now in this time, we are going to use two laser beams. Okay, we are going to direct two laser lights like this. Okay, and my dear children, now you have to observe what is going to happen. So this is our activity. Pretty simple. What do you have to do? Just take it, direct it and observe. Very simple. Okay. Here the thing is that you have to use two different laser beams and a cardboard with a silt. Through the silt you have to direct it. Right? Okay then. So my dear children, this is the way of doing the activity. Pretty much simple. Okay. Let's once again head on to the laboratory and we'll continue with this activity now. And let's observe what is our observation. Once again then we'll come down to the classroom and we'll discuss about that observation, and from that observation what is our conclusion. So my dear children, within this activity I have two laser boxes. Now two laser beams are directed towards the plane mirror over here through this cardboard sheet that has a small bit of a hole, small line of a hole like this. Okay, so through the hole, right, through that hole, two lines of or two laser beams are directed towards the plane mirror which is over here. Now our aim is to observe these laser beams by using the plane mirror. Remember, these laser beams are very dangerous. So if you are at home, right, or if you have any lasers at your home, don't even try to look at these things from your direct naked eye. Okay, so these things are very dangerous. So our aim is to identify and observe these two laser beams from the plane mirror. Okay, so if you can see, right, if you observe it very clearly, you can observe it like this. The plane mirror, within the plane mirror, the image is going to fire up two laser beams towards you guys through this hole which is placed between the cardboard sheet. Okay, so that would be our observation. So let's see whether we can observe this thing. So if you observe this thing very clearly, my dear children, now you can see that if you directly observe through the mirror, you can see that the laser beams are directed towards you guys. But however, you won't be able to observe this cardboard sheet, but you can observe some kind of an image which is created inside the mirror, and that image is the one which is directing two laser beams towards you guys, right? But if you observe it very clearly, that two laser beams are being directed not from here but from here. Okay, so by using these types of two laser beams, we can find out the images created by the plane mirror. Okay, so within next activity, my dear children, now I'm going to show how to find out the position of the image created by these plane mirror images. Okay, usually in a plane mirror image, we can find out the position of the image which is created by using the same phenomena like in here. Now in over there we'll be using two different light rays directed like this, and we'll be drawing out a certain ray diagram in order to find out the position of the image. So we'll find out how to draw it in our next activity. Right, my dear children, so we conducted the activity, right? Now it's time to investigate about the observation from that particular activity. Okay, so let's see the observation. So observation was quite simple. Okay, our observation was quite simple. What is that? So in the activity, the pointy object is the silt made in the cardboard. So our pointy object was that silt made in the cardboard. The light rays reach from silt, get reflected by the plane mirror, and from an object behind and form an object. It should be form, right? So here it should be form, right? Not from. Form. So get reflected by the plane mirror and form an object behind the mirror. Now, what is our observation? Like in the previous activity, my dear children, here also you can get the same observation. What is that? Here also you can observe that it is going to reflect from the silt, and it's going to reflect from the plane mirror, and it's going to come towards your eyes. So that, my dear children, it is going to form an object behind the mirror. Like in the previous activity, we can observe the object same as the previous activity, which is the object is now seems to be behind the mirror. However, it is not. Okay. However, it is not. Object is in a different place. However, you can observe the object like it is in the mirror. Okay, like it is in the mirror. Then, according to the observation done in activity, we can illustrate the ray diagram. For that, let us engage in activity. So now, my dear children, we are going to draw out the ray diagram related to these two experiments. So to draw the ray diagram also, we are going to do an activity. Okay. So through an experiment, once again we are going to draw out our plane mirror reflection, the ray diagram related to plane mirror reflection, right? Okay, then now let's see what is the activity that we can use to draw the plane mirror reflections. Okay. So here we are going to draw the ray diagram only. Okay, ray diagram only, my dear children. So the pointy object, we took that in the previous activity. It's time to draw how does the image is getting created within the plane mirror from those two activities. Now here we are discussing only about the ray diagram, drawing how to draw out the ray diagram related to that one. So to do this activity, my dear children, it's very simple actually. We'll be needing an A4 sheet. Then we'll be needing a ruler. Then protractor. Then a pencil. Right? Then a pencil. So these are the materials which we need. So it's very simple, my dear children. We are going to draw out the ray diagram over here. Okay. So only the ray diagram, no. So we use the pencil, protractor and the ruler and the A4 sheet. Now we are going to take a pointy object or else a certain point. We are going to draw the plane mirror surface and we are going to direct two light rays. Now over there we directed two light rays. Can you remember? Right? We directed two laser beams. Right? Two laser torches. We directed two laser torches towards the plane mirror surface. Then we got the reflection in order to get the image. Okay. So here we are directing those two light rays towards the plane mirror. And we are going to observe, right? And we are going to see how the image is going to form. We did that thing. Now it's time to draw the ray diagram related to it. So in the same way, we are going to draw out two straight lines towards the plane mirror surface. Then we are going to reflect those two light rays according to the laws of reflection. You know what are the laws of reflections, right? Actually, there are two laws, but however, we are going to use only one law because already we are using the first law in order to draw the three lines, normal, incident ray and the reflected ray on the same plane. And the other important rule is the one Okay, oh, the other important law is the main thing which is needed to be followed when drawing a ray diagram related to plane mirror reflections, right? So what is that? The incident angle is getting equal to the reflected angle. So always during a reflection, you have to measure these two angles and draw the ray diagram. Okay, that's why we are using even the protractor to get the angles. Right, now let's head on to see the method then. So method is quite simple. Draw a straight line on the sheet of paper to indicate the plane mirror. Mark a point about 5 centimeters away from the mirror plane. Point from the object. Now it's very simple. What you have to do, you have to draw out mirror surface like this, my dear children. Then make sure to dark one surface. Then what you have to do, let's see. Then mark a point about 5 centimeters away from the mirror plane. That means point to form the object. Point form object. So like a point to form the object. Let's keep it like this. So we'll mark it as point X. That means this is a point form object. Then what do you have to do? Then, my dear children, starting from this point, draw two inclined light rays to the mirror plane. Now, my dear children, what do you have to do? You have to draw two straight lines. From this point, two straight lines. So, I'll use two different colors to indicate it. One. Then, my dear children, another one. Two. Okay, like this, you have to draw two inclined ones. Remember, inclined ones. Right. So, two light rays. Then what do you have to do? Mark the points of the incidence and construct the normal lines. So, you know that you can draw the normal lines by using, now you have to draw a perpendicular, no? So, you have to draw it by using the set square. Okay, or else you can even use the protractor as well. But however, using a set square is more convenient. So, by using a set square, you can draw the perpendicular. So, let's imagine that the perpendicular is like this. So, I'm going to use my pen now. This is just an illustration, no? So, this is the normal line. This is the normal of the first one, okay, like this. So, this is the normal. This is just an illustration, my dear children, okay. So, now what you have to do? You have to take this particular angle, and for the same angle, you have to do the reflection like this, okay. In the same way, get the other angle and do the same reflection like this, okay. So, let's see. Mark the points of the incidence and construct the normal lines for the two light rays drawn. Measure the angles of the incidence and mark the angle of reflection equals to them. So, like in this, like I explained, my dear children, what you have to do? You take the angle over here. Then, to have that same angle, you have to reflect the light ray like this, okay. And remember, the two angles at the either sides of the normal and the reflected ray and the incident ray should be equal to each other. Okay, these two angles should be equal to each other. And in the next one also, you have to get the same thing, right? It's very simple. So, this is how to draw the ray diagram then. Okay, this is just an illustration, a simple figure. Okay, now what do you have to do? Now construct the reflecting rays. Extend back the reflecting rays by the dotted lines to meet them together. Now, can you remember, my dear children, we observed the image within the mirror, not from the outside. We observed the image within the mirror. So, you know that the image is going to create within the mirror. So, what do you have to do? You have to join these two lines like this. Now, you have to get the position of the image. Position of the image. You have to extend these two lines, reflected lines. Okay, you know that these are the reflected rays. Let me show you the reflected rays. So this is the incident ray which is coming towards the mirror. This is the reflected ray. Now this is one. This one is the reflected ray. This is the incident ray which is coming towards the mirror, and that's going to reflect like this. Okay, now what you have to do is you have to extend these two lines. You have to keep the long ruler and you have to extend these two lines like this towards the mirror. Okay, towards the mirror you have to extend. Towards means actually here, like this you have to extend. Now after extending it, you can get the image. Okay, so this is the object. So once again, I think you could remember, we observed the image within the mirror. So it's not going to create outside. Okay, so therefore you have to take the two reflected rays and join those things, right, towards the towards the mirror. Those things are getting aligned each other, or those two reflected rays are getting collected each other within the mirror. So towards the mirror you have to elongate these things. So at the point where the two reflected rays are going to intersect, we can observe the image. So here, like this, we can get the image position, my dear children. So this is the object. So this is the way of drawing out the ray diagram. Okay, this is the way of drawing the ray diagram of plane mirror reflection. Okay, now within this activity, my dear children, we have to use at least 2 light rays. Okay, at least two light rays are needed. 2 is enough to draw a ray diagram. At the point of intersection of the two reflected rays, you can observe the image. Over that place, you can observe the image. Okay, so this is the way of drawing the ray diagram then. So once again, given here, mark the point where the reflected rays meet together when extended back. That is the point where the image is formed. So like I said, you have to extend the two reflected light rays. At the point where these two reflected light rays are going to meet, you can observe, right? You can observe the image. Okay, that is the place where you can observe the image. Right, my dear children. So this is the way of drawing the ray diagram then. Now after drawing the ray diagram, let's see what are the things that we can observe, or else what are the things that we need to get, right? So after drawing out the ray diagram related to the above one, you have to do this thing. What is that? Connect the object and the image by dotted lines. Now you have to connect the image and the object by dotted lines. That means like this. See, now this is the diagram which been drawn according to the laws of reflection, my dear children. So this is the light ray, the two light rays. These are the two light rays which are coming, and these are the two reflected rays that are going. So what you have to do now, you have to join the image and the object by using a dotted line. Then what do you have to do? Measure the distance between mirror and the object. So object and the mirror. This is the mirror now. This is the object. So you have to measure the distance between mirror and the object. You have to measure the distance between mirror and the object. That is also referred as the object distance, my dear children. It is referred as the object distance. And the distance between the mirror and the image and the mirror, this is referred as the image distance. So you have to measure the object distance and the image distance, right? Then what you have to do? Confirm the object distance is equal to the image distance. Then, my dear children, check whether these two distances are getting equal to each other. Right. So we have to do this thing after doing the activity. Okay. That means we have to draw out this thing and we have to see whether this thing is getting equal or not. Right then. So this is the way of doing the activity, my dear children then. So let's head on to the laboratory. We'll continue to draw the ray diagram related to the plane mirror reflections. And let's see whether these two are getting equal or not. So my dear children, I think you can remember in the earlier activity we did an experiment by using two laser beams to show the reflection which is going to happen through a plane mirror. Over there, we observed the image created by the plane mirror. Now, this is same as to that practical or else the activity. However, here within this practical, we'll be drawing the related ray diagram by using our instruments over here. Okay, so we are just drawing out the ray diagram related to the previous activity within this activity, my dear children. So you know that there are two main activities or there are two main laws related to the plane mirror reflections. So in a plane mirror reflection, you know that always the incident angle is equal to reflected angle. So by using that principle, we'll be drawing the ray diagram related to plane mirror reflections. So I'll use the ruler first. So this is the, in here at the middle, I'll draw the plane mirror. So this is my plane mirror, my dear children. So over there, here, this is the darker surface. Right? And over here at my side, the reflective surface. Now I'll mark a point like in here. So I'll name this point as X. So my dear children, now this is the point X. Now from point X, we'll be drawing two straight lines towards the plane mirror, which is marked over here. So this is the mirror surface. So we'll draw two straight lines towards the plane mirror, and by that way, we'll get the reflections of those two straight lines. Okay, actually straight lines means in here, light rays. Okay, so we'll get the two reflections. So when we are taking the reflections, remember the angle between the incident ray and the normal should equal to the angle between normal and the reflected ray. Okay, right. So we'll draw out the two straight lines first. So before drawing, I'm going to use the perpendicular, right? So this is the perpendicular, one perpendicular. So this is the first perpendicular, my dear children, as you can see. See, it's exactly 90 degrees. So now what I'm going to do is I'm going to draw out an angle, right? So let's take around 30-degree angle. From here, let's take a 30-degree angle. So here, 10, 20, 30, 30-degree angle. Once again to here also 30-degree angle. Make sure you are marking these angles. It should have to be very accurate, okay? Now let's right. Once again, let's see how much is the angle now. Yes, it is exactly 30 degrees. So we'll take 30 to here and we'll draw the reflection. Right. So this is the first light ray from point X. right? Now let's head on to get the second light ray. I'll use a pen for it. So the second light ray, like this, then the perpendicular. Now let's measure the angle here, 10, 20, 30, 40, 45 and 47. So 47. So 47 each. I took 47 degrees each. So here to here 47, then here to here 47. Now let's draw the angle. First of all, the perpendicular. Then the reflected ray. Right. So my dear children, now we have drawn two straight lines. This is the first straight line from the pencil, which is coming towards the mirror. So this is the mirror, right? This is the point X, the object. This angle we took as 30 and here also 30. This is the incident angle of the first light ray and this is the reflected angle of the first light ray. So both are equal. So here 47. Here also 47. The incident and the reflected angles of second light ray. Now these are the two light rays which are going away from the mirror, or two reflected light rays. Now we'll draw the reflected light rays towards the mirror, then once again to the beyond the mirror in order to get the image. Right. Now this should be our image, my dear children. This is the object. Right. So now what I'm going to do is I'm going to check how much is the distance between object and the mirror. So I'll use a straight line and I'll check how much is the distance. So let's measure. So as you can see here, it's around 6.7. 6.7. Now let's take the distance between image and the mirror. Once again, I'll use a straight line. Now let's check. When you check it, it's nearly around 6.7. Nearly around 6.7, right? So here also 6.7. So the distance between, now this is the distance between mirror and the image. This is the distance between object and the mirror. As you can see, it's very clear to us that the distance between object and the mirror is getting equal to distance between image and the mirror, right? If you draw it very accurately, then you can get these answers, my dear children. However, there can be like 1 or 2 millimeter difference. It's because that when we are drawing these things, there can be like simple bit of errors, right? But there can't be any errors like few centimeters. I'm just talking about there can be a very slight more difference between the real and the real means the object and the mirror length, and the mirror and image length. Like there can be a very small tiny bit of errors like 1 or 2 millimeters, right? Not a dramatic one, not a dramatical one, but however like 1 or 2 millimeter there can be a small bit of a difference, because when we are drawing lines, right, there can be small bit of errors, right? Technical errors, right? Then, so within this activity, it's clear to us that during a plane mirror reflection, the distance between object and the mirror is getting equal to the distance between mirror and the image. It's quite obvious to us. And also, This is the mirror, my dear children, and within the mirror, image is getting created. When you observe images through a plane mirror, you can see that the image is getting created within the mirror. Okay, so this is the activity that we have conducted to draw the ray diagrams related to plane mirror reflections. Now let's head on to the classroom once again and we'll observe the other contents in the lesson. Right, my dear children. So we conducted the activity and I think you could see that now nearly it's getting equal. Actually, it's not nearly. 100% it is getting equal. It should get equal, but however, when we are drawing the ray diagrams, my dear children, there can be human faults, small bit of human faults. Okay, that means like sometimes the angle is somewhat getting different. Actually, if the angle is getting different by 0.5 degrees, 0.1 degrees, then you won't be able to get the same exact answer, right? So however, my dear children, if you get the nearest answer, the two answers are getting equal. So our observation was quite simple. What was that? The object distance is getting equal to the image distance, my dear children. By drawing out that particular ray diagram, we can come into that conclusion. Okay, right. So we'll write down the observation. Object distance is equal to the image distance. This is our observation, right? This is our observation, my dear children. So for the conclusion also we can get the same thing. So that's why that is why I haven't mentioned the conclusion thing over here. The same thing goes no. So it's very simple. What is that? Object distance is getting equal to the image distance, my dear children. So within a plane mirror reflection, we can observe this thing, right? And also it is a specific property related to the plane mirror reflections. Always the object distance is getting equal to the image distance. So this is the observation that we can take from the activity, right? All right then. So let's head on to see the next content. So construct a ray diagram to show how the image is formed of a point form object kept 8 centimeters away from a plane mirror. It is suitable to use an A4 sheet of paper for this. Measure the object distance and the image distance. So what you have to do, my dear children, you should follow this thing at home. You have to do the same exact way which I have did, okay, at our laboratory. You have to take the A4 sheet, you have to take an A4 sheet, then what you have to do, you have to draw out, right, the structure or else the ray diagram related to this particular reflection. Okay, here you have to place the object like 8 centimeters away from the mirror surface. Then like in the same way, draw 2 straight lines. Those are the incident rays. Draw 2 straight lines towards the plane mirror at a certain angle. Then draw the normals, which are the perpendiculars to the mirror surface to the incident point. Then, my dear children, reflect the light rays so that the incident angle is getting equal to the reflected angle, right? In both of these light rays, you have to follow up the same method. Now, what do you have to do? Now, my dear children, join the 2 reflected rays towards the mirror, right? Then get the point where the 2 reflected rays are getting intersected. This point is the point, right? This point is the point, my dear children, where the image is getting created. Now, join by using dotted lines the object, that means the point of the object and the point of the image. Now find out the distance between object and the mirror and the distance between mirror and the image. Check whether these two are getting equal. If you are going to draw it correctly, definitely for sure these values should be equal to each other. Okay, these values are getting equal to each other, right? Now, like I said, my dear children, when we are drawing these figures, there can be some amount of errors. Like some amount means not huge errors, like from a 1 millimeter or like 0.5 millimeters, it can vary. However, my dear children, if it is 8 centimeters, definitely like 8.1 or 7.9, that means you can give it up to 0.1 centimeter of a tolerance. That means 1 millimeter of a tolerance can be taken, no problem. Okay, because of human errors, now when we are drawing these things, we are drawing by our hand, no, so there can be errors. So because of human errors, the values can change like up to 1 millimeter, however not by a huge value. Okay, right? So if you are going to draw it too much accurate, very accurately, then you can get the answer as exactly 8. But however, right now, because of those changes, the value may differ from 1 millimeter. Okay, if so, don't get disappointed, your diagram is correct. Okay, your diagram is correct. Because of like human errors, we got like we are going to receive the answer like 1 millimeter or 1 millimeter behind of 1 millimeter greater. You get the idea, right? So I hope that you get the idea, my dear children. So this is the way of drawing out a certain ray diagram related to plane mirror reflections. So remember, when drawing ray diagrams, at least we have to use two light rays, okay, two straight lines, and always we are going to draw the reflection by using the two laws. Actually, one law is the one which is useful over here. That particular law is always we have to take the incident angle to be equal with the reflected angle, right? Okay then. So I hope that you will follow up this assignment at your home and you will do it, okay, like the same way which I did in our laboratory. Right then, so let's head on to see the next content then. So you have already learned in grade 6 and 7 some of the characteristics of images formed by the objects kept in front of the plane mirrors. So we have learned about some characteristics, right? We discussed that in grade 7, plane mirror images cannot be focused to a different screen. Always these images are getting created within the plane mirror itself. Okay, so we won't be able to focus that into a different screen. So therefore, we identified that these images are virtual images, means that they cannot be projected to a different screen. This image is created within the mirror, my dear children. And the other thing, can you remember the word ambulance? So I think in grade 7 we studied with this thing as well. Okay, I think that you guys also have studied. So ambulance word, right? Ambulance word is not, I mean like it's not in the form, I mean like it's been it's been printed on the ambulance by changing the left and right sides. It's mainly because the lateral inversion which is going to occur within the images created by the plane mirrors. These images are laterally inverted. What do you mean by the lateral inversion? Lateral inversion is the process of switching left and right sides of a certain thing. Here, within the image created within the plane mirror, it has this property where the lateral inversion, right, which is the lateral inversion. Lateral inversion means within the image created within the plane mirror, the lateral inversion is going to occur. So lateral inversion means switching of left and right sides. Okay, switching of left and right side. In simple, this is letter E. So if you place letter E, then within the plane mirror, it is indicated as, right, within the plane mirror, it is indicated as like this. Left and right sides is going to switch. Okay, left and right sides are going to switch. So my dear children, this is referred as the lateral inversion. lateral inversion. So the images created by plane mirrors show this lateral inversion, and also the other thing is that those things are virtual. Virtual means cannot be projected to a screen. And the other thing is that, now I think you also have this experience when you go in front of a plane mirror, right? You can observe the image of you. So that image is very similar to you, same in size, and all the other aspects are same. That means the object size and the image size is also same, right? So within the image created by the plane mirror, the object size and the image size is getting equal to each other. Okay, object size and the image size is getting equal to each other. Within this previous activity, we identified another feature, that the object distance is getting equal to the image distance. So like that way, we have studied several properties now regarding the plane mirror images. Okay, so in recalling them, let us do an activity to study the characteristics of images formed by plane mirror. However, my dear children, now I am going to recall these things for you guys. So let's head on to our laboratory to do this experiment. Okay, so this experiment is going to recall you about the features, or else about the properties of images created by a plane mirror. However, before that, let's see what are the materials that we need and what is the method of doing the activity. So let's head on to see the materials first. So studying the characteristics of images formed by plane mirrors. So here we are going to study the features or characteristics created by the images in a plane mirror. Okay, so first of all, to do this activity, we'll be needing these materials. We'll be needing a mirror, then A4 sheet, a ruler, then some letters, letters like O, F, B, D, simple D, simple B, like that way, several letters. Okay, right? So these are the ones that you need, right? So you'll be needing an A4 sheet, plane mirror, a ruler, and some letters. Okay, right, now let's head on to see the method. Fix the plane mirror vertically to the stand. Place each piece of cardboard on a letter is drawn, on which a letter is drawn in front of the plane mirror. Observe the image of the letter through the mirror. So it's very simple. You have to keep the mirror vertical, right, by using a stand. Then you have to keep that object. Here the object is the letter which you have prepared. Okay, so you have to keep it near the mirror and you have to observe like what kind of a shape, okay, it is going to give out. Is it the shape of the same letter or a different one? See whether the image can be taken onto a screen. Now observe whether you can take this image onto a different screen. For sure, you know that we won't be able to take this into a different screen, right? Then repeat the activity keeping some other objects in front of the mirror. Then you can use other different objects as the other letters, right? So you keep these objects or the letters in front of the mirror and observe whether you can get an image same as that one or else any other. Are there any differences? And my dear children, check what will happen to the size and the shape of the image as well. Okay, then tabulate your observations in the table. Now you have to tabulate the observations in the table. What is the table? So let's head on to see the table then. So this is the table, my dear children. Under the observations, you have to complete this thing, right? First of all, we have to do the activity, then we have to complete the table regarding the observations. See, so letter B, F, D and O, simple D and O, how the image is seen, upright or inverted. Upright means in the same direction as the object. Inverted means to the opposite direction as the object. That means upside down, inverted. Then whether lateral inversion occurs or not. Lateral inversion, can you remember? Switching of left and right sides. Equality of the size of the image and the object. Equality means you are going to compare the size of the object and the size of the image. Then you are going to check what is the size, what happens with the size, whether it is getting equal or whether those two are different. Then finally, whether the image can or cannot be taken onto a separate screen. Then in the next one, we are going to check whether the image can be taken onto a separate screen or not. Right then. So this is the way of doing the activity, my dear children. Okay. So we'll go ahead to the laboratory and we'll point out these letters and we'll see what's going to happen over there. So my dear children, I have with me several objects. There are different letters written on these sheets. The letter D, simple D, right? Then capital B is there. Capital F is there. And O, right? Then I have another plastic material. So this is also a type of an object. So what I'm going to do is I'm going to place this thing near the mirror and observe what are the features of the image created by this object. So when you place it like this, right, you can see that the image is getting created within the mirror. So this image is very identical to the object, right? And the other thing is that towards the direction, I mean, like you can see that the point of this object is upward. So in the mirror image also that point is upward. So we can say that the image is upright. Upright means to the same direction as the object, the image is getting created within the mirror, right? So this is an upright or else erect image. Image is erect or else upright. Then the other thing is that, my dear children, we won't be able to take this image to a different screen. As you can see here, it's always created within the mirror, inside the mirror. As these images cannot be taken to a different screen, a separate screen, these types of images created within the mirror are referred as virtual images. Virtual images. There are some kinds of mirrors, right, where the image can be taken into a different screen, right? I think in grade 7 you have heard about the convex mirrors. So convex mirrors has that ability, right? Convex mirrors has that ability, okay? Concave mirrors also has that ability. Concave mirrors has the ability. Convex mirrors will not be able to provide any kind of a, like real images in convex mirrors. But however, in concave mirrors, not in the convex, my dear children, concave mirrors. In concave mirrors, I think in grade 7 you have identified about the concave mirrors. Even we took some images related to the concave mirrors. So in concave mirrors, we can take the image to a different screen. So in concave mirrors, we can create real images in concave mirrors. Okay. So my dear children, there is another special property in the images created by plane mirrors. However, in order to observe this special property, we have to use letters. That's why I have prepared these letters. So first of all, I'll use this letter O, right? And I'm going to direct it towards the mirror. When I'm directing this board towards the mirror, always I'll keep my fingers folded like this in my left hand side. This is my left hand. And in my right hand side, I'll keep the fingers open. Okay, right. So this is my left hand. This is my right hand. So observe the image very clearly. So as you can see, this image, I think, does not show any kind of a difference like to the previous ones, right? So that image, the letter O, is also the same as the previous one. However, let's observe another different board then. So I'll keep this one. I'll use letter B. So this is my left hand side. You can see that the letter B, the shapes of the letter B towards my left hand side. So this is my right hand. Let's see. So as you can see here, now it's very clear to us that there is a change in the left hand and right hand directions. There's a clear change, right? There's a clear change between the left and right directions, my dear children. We'll observe another one. This is simple D, right? So let's observe it. So simple D is now like simple B when you're observing from the mirror. Once again, let's observe another one. This is capital F. Let's observe capital F. Capital F is also the same, my dear children. You can observe laterally inverted F. This thing or this special property is called as the lateral inversion. In the lateral inversion, my dear children, left and right side of the image is switched. This is referred as the lateral inversion. The left and the right sides have been switched within the mirror, within the image created within the mirror. Okay. So, in order to observe this left and right switching thing, I'm going to use this letter O once more, and let me color a one half of the letter O by using this pencil. So this is right. So I'm going to color one half of it. Right, now as you can see here, now one half has been totally, from the letter O, one half has been totally colored by using the pencil. Now I'm going to direct it towards the mirror once more. So here we go then. Observe it very clearly. Or now when I'm observing my dear children, I have highlighted the right hand side. See, this is my right hand. This is the colored area. So as you can see here, my dear children, this is the area which I have colored by using the pencil. So in order to get a good view, I'll use a marker pen and I'll color this half so that you can observe it very clearly. Only one half, okay? Right. Now you can see it very clearly. This is my right hand side, my dear children. The right hand side. I told you that when I'm directing it, always I'm keeping my fingers open in my right hand side, and in my left hand side I'm going to fold the fingers like this. Okay. Right now I'm going to direct it. See, this half is at my right hand side. Now let's direct it. Okay. Right. So when you are directing it towards the mirror, you can see it very clearly, my dear children. Right? See, it has been switched to the other side. Okay, it has been switched to the other side. So when I am directing this thing towards the mirror, my dear children, you can clearly observe that the image is getting created within the mirror by switching left and right hand sides. You can clearly observe that the colored area now, it's in my, see, left hand side, not in the right hand side. Okay, however, if I'm going to keep it like this, now we can see that it is at the right hand side. See, this is my right hand side. You can observe it within my right hand side. When I'm directing it towards the mirror, what will happen? It will switch the directions, left and right. So let's see whether the image is getting upside down or not. That means if the image is getting inverted or not. So in order to observe that, once again I'll mark a dot in here at the top of the letter O. Now let's observe. So as you can see here, there is no change in it. On the top you can observe the dot. In here also, when I keep it like this, you can observe at the top there is a dot. So there is no inversion. I mean, like inversion in here. Vertically it's not getting inverted. However, laterally it is getting inverted. Left and right hand sides are getting switched. Upside down thing is not going to happen. Okay, that's why I told you that these images are erect images. Okay, these images are erect images or else upright images. So we have observed several features related to the plane mirror images, my dear children. Now let's head on to the classroom and we'll complete the table. Right, my dear children. So we conducted the activity. Right, now I'm going to fill out this table by using those observations. Right, now let's see the first one. Letter B. The image was upright and it is going to create the lateral inversion, and the size is equal and cannot be taken into a screen. Letter F. F is also upright. Right, upright means in the same direction as the object, no difference. Lateral inversion occurred. Then object and the image size was equal to each other. Then cannot be taken into a screen. So actually all the images were created within the mirror, my dear children. So we can write for each and every column without any trouble as cannot. And here also each and every image was equal to the object size. So therefore here also we can mention as equal. Right. Then my dear children, the uprightness or the invertedness. All the images created was upright. Quite obvious. Upright. Then the lateral inversion. For letter D, lateral inversion occur. But however, for letter O, my dear children, for letter O, I can't say whether the lateral inversion has occurred or not. But however, right, when you divide it to two different planes and when you keep a certain dot, you can clearly observe that the dot is going to switch the direction. Right? Within the letter, we won't be able to observe. Now, when you keep the letter directly towards it, we won't be able to observe. Now, when you go in front of your mirror, plane mirror at your home, and when you're going to stand up like this, you can observe your image on the mirror. However, my dear children, what has happened over there is your left and right hand sides are being switched, but you won't be able to see this thing very clearly as you are bilaterally symmetrical. So if the letter is bilaterally symmetrical, okay, then my dear children, we won't be able to observe that lateral inversion thing. Okay, in symmetrical objects and in symmetrical letters, we won't be able to observe the lateral inversion thing. Okay, so my dear children, here also it is going to occur. However, if the letter is in the same way as letter O, we won't be able to observe it very clearly. Okay. However, when you keep a point or else a dot from a certain side, then we can observe. Right? Then we can observe the switching process or the lateral inversion. Right then, so these are the observations, and according to observations, my dear children, in each and every column you can observe the same thing. Here all the images are upright. Within all the images, lateral inversion has also occurred. Within the all images, object and the image size has got equal. All the images cannot be taken into a separate screen. Okay, that means those things are virtual. Right. So my dear children, here you are given special points. Let's see. Changing the right hand side and the left hand side of the image is known as the lateral inversion. So like I said, my dear children, switching of left and right sides is the one which is called as the lateral inversion. Then if the image can be taken onto a screen, it is known as a real image. Then the other thing, real and the virtual. So if you can take a particular image to a different screen, not the mirror, not within the mirror. This is not talking about the mirror surface. Here we are talking about a different screen. I think, can you remember, we learned in grade 7, right? We learned in grade 7 that the concave mirrors, when you place a certain candle in front of a concave mirror, what will happen? We can get the image onto a different screen in front of the mirror. Now those kind of images are, which is created by the concave mirrors, those kinds of images are referred as real images, because the image can be taken into a separate screen. However, these things cannot be taken into a separate screen. Therefore, these images are virtual images. So, a real image can be taken into a screen. Virtual image cannot be taken into a screen. Virtual image is creating within the mirror. Okay. So, that kind of an image is created within the mirror, not outside it. Next one. If the image can be taken into a screen, then it is real image. If image cannot be taken, then it is called as a virtual image. Okay. Then my dear children, special point is given. Letters like O, A and X cannot be identified under lateral inversion, as these letters are symmetrical. So like I said, my dear children, because of the symmetricalness, right, because of the symmetry of these letters like X, O, A, we won't be able to observe the lateral inversion. However, if you divide it along a certain axis, if you divide it into two parts along an axis, and when you keep a certain point from one side of the axis, then my dear children, you can observe that point has got changed within the image. It's because of the lateral inversion. In these things also lateral inversion going to occur, but we won't be able to observe that thing clearly because those letters are symmetrical, right? Even you go and stand up near a mirror, your image is also very similar, right? It is very similar to the image of you. Okay. However, my dear children, left and right sides has got switched. Okay, you won't be able to observe it because you are also bilateral symmetrical. In symmetrical objects or figures, this lateral inversion thing is not that much clearly observable. However, it is going to happen. Okay, right then. So these are the properties related to the plane mirror images, my dear children. Okay. Properties. So we have identified 5 different properties. What are those 5 different properties then? Number 1, object distance is equal to the image distance. All images are upright. All images are virtual. All images are equal in size to the object. All images are laterally inverted. Right? 5 properties. Right then, my dear children. Now it's time to write down these properties then. So Characteristics of images formed by the objects kept in front of a plane mirror can be listed as below. So we are going to list down these properties then. Okay, so we'll list down the properties. Number one, my dear children, images are upright. Okay, images are upright. Number two, images are virtual. What do you mean by virtual? Cannot be taken to different screen. Cannot be taken into different screen. Cannot be taken into a different screen. Right? So images are virtual, cannot be taken into a different screen. Number three, image size is equal to object size. Image size and the object size are equal to each other, my dear children. Then the next one, image distance. Image distance is equal to object distance. Image distance is equal to object distance. Then finally, images are, or else lateral inversion occur. Lateral inversion occur. What do you mean by lateral inversion? Left and right sides have switched. Right. So these are the properties, my dear children. Number one, images are upright. All the images are upright. Okay. All the images are upright images, my dear children. So this is also called as erect. Erect images. Erect. Next one, images are virtual. That means cannot be taken into a different screen. We won't be able to take these things into a different screen. So therefore, these images are referred as virtual images. Next one, image size is equal to object size. Image size and the object size are equal to each other. Next one, image distance is equal to object distance, right? So distance between image and the mirror is equal to the distance between object and the mirror. Distance between image and the mirror is the image distance. Distance between object and the mirror, that is the object distance. So these two are getting equal to each other. Then finally, lateral inversion occurs. Lateral inversion occurs. Lateral inversion means switching of left and right sides. Okay. So within the images, left and right sides have switched. Okay. these sides have been switched. So these are the properties that we can observe within the plane mirror images, my dear children. So by doing several activities, we came into these observations, and from that we can come into these conclusions, my dear children. Okay, so I hope that you got the idea about the plane mirror images right then. So my dear children, we conducted several activities to identify properties of plane mirror images, right? So within that, by doing this, I'm going to finish up this chapter. So within this chapter, we discussed about mainly the plane mirror images and their properties. So in our next chapter, we'll discuss further things related to the lesson part.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.